Hi, scholars. So let's say we're given a proportion, let's say 2/5 equals 4/9. We say we want to check and see if this is actually true, right? This is a statement, right? Every equation that you write is a statement. And we've learned before, right? It could sometimes be true, could always be true, could never be true. And so one way that we can always check to see if a proportion is true is we can cross multiply. This will always work, okay? And so I can say that 2 times 9 is equal to, right, 5 times 4. And we put a question mark here because we're checking, we're seeing, we don't know if they're equal. And in fact, 2 times 9 is 18, 5 times 4 is 20. They're not equal. Because they're not equal, that means that this initial proportion is incorrect. It is wrong, right? Now, there's a trick here. This is something that does confuse students a lot, right? So we're going to take a quick look at it. For example, let's go to 2/5. Here's a fraction. So it's a very common mistake to say if I want to come up with another proportion, or if I want to come up with another fraction that's equal to this, 2/5, that all I have to do is add the same number on the top and the bottom. Okay? So you see, because this is the idea that, oh boy, if you do something to one side of an equation, you have to do it to the other side, right? So if I plus 3 on the top, I got a plus 3 on the bottom. That's the idea, right? This is a misconception. We can also call it, it's just sort of a mistake, okay? So this, what I'm showing you right now, is not how proportions work. It's not how proportions work. And you can check, because you can see, we can verify that it's not the case, right? By checking, is it true that 2/5 equals 2 plus 3 is 5, 5 plus 3 is 8? Is this true? Let's check it. 2 times 8 is 16, 5 times 5 is 25. Nope. That is not true, right? This right here is not true. These are not equal, right? However, there is something that we could do with the 3's to create a proportion, okay? What we could do with the 3's if we wanted to, let's go back to our 2/5, and I say I really want to make a proportion, and I want it to have something to do with the 2 and the 5, and then I'm going to add a little bit, something to do with the 3's, right? Well, remember, when two fractions make a proportion, really what we can do is we can think about the numerators and denominators getting larger, but getting larger multiplicatively, getting larger at the same rate multiplicatively, right? So for example, what happens if I multiply the top and the bottom, the numerator and the denominator, by 3? Do I get a proportion? Well, let's check it out. Is it true that 2/15, right? We're verifying. Does that in fact equal? And now we have what? 2 times 3 is 6. 5 times 3 is 15. All right, let's check. Let's check it out. 2 times 15, we'll do it in a different color even. 2 times 15 equals 30. Does 30 equal 5 times 6? You bet it does, right? So this right here is correct, right? And in general, if we say 2/5, right? So we can actually list, right? We can say that 2/5 equals to 4/10 equals to, here we learned 6/15 equals to 8/20. Do you see this pattern, right? We're doing a pattern, right? Times, right? Times 2, times 2. Times 3, times 3. Times 4, times 4, right? We can sort of keep going, and actually we can write any fraction that is equivalent to 2/5 as 2 times some x over 5 times some x. And now that x could be, in this case, right? In this case, x was 2. 2 times 2 is 4. 2 times 5 is 10. In this case, x was 3. That's what we did up here, 6/15. In this case, what was x? 4, right? 4 times 2 was 8. 4 times 5 was 20, right? So in general, this works very well. This is correct, okay? But You cannot say that 2 over 5 equals, for example, 2 plus x over 5 plus x. No, that's not how proportions work, okay? And we can even reason about it just very briefly with the measurement model, right? You can't tell me if I have a ruler here and some length, right, here, that if I just add 1 to this ruler and add 1 to the length, that the same number of rulers is going to measure this new length, right? That's not how it works. You can verify it, that that's not how it works. This new length with the ruler, right, is not that they're not going to be the same number of rulers to measure that length there. There's no way. And again, if you sort of forget this, right, you can do exactly what we just did. We just tried a number. We explored it, right? That's what we did here, and that's what we did here, right? We said, let me see what happens. I don't know, maybe if I add 3 to the top and the bottom, that I'll end up with a true proportion. And we said, no, doesn't work, right? And this was done through oh my goodness, this was done through exploration, okay? And lots of math. It helps to be curious, to just say, I think this thing might be true. Let me check it, right? Okay, and this takes time, of course, but it's very nice. It's a very nice way to sort of interact with math, because you don't want to sort of memorize rules. As much as possible, you want to make sense of why the rules work, right? That's more interesting than just memorizing.